for in our next session, we will also talk about a very important emerging technology, which is green hydrogen. For that, I'd like to invite Elin Steinsland and Baptiste Merlet to join me on stage, and we are connected remotely to Stefan Kaufmann, I think. I've got one microphone. There's a second one. Hello.
Hello.
Hello. Good morning.
Sit down. Hi again.
Have a seat. So is Stefan Kaufmann with us? No?
Can you hear me?
Oh, yes. Hello. Good morning.
Hello, good morning from Berlin. Sorry, I could not catch my flight yesterday evening, so it was not possible to be in Nantes in person this morning.
On the plane, yeah.
I'm happy to join remotely.
Well, thank you for joining us remotely. You're the Innovation Commissioner for Green Hydrogen at Germany's Federal Ministry of Education and Research. And Germany has ambitious goals. It's aiming for 10 gigawatts of green hydrogen until 2030. That would mean 30 gigawatts of installed renewables producing the hydrogen. One share of these installed renewables will be offshore wind energy. Tell us a bit more about these plans. How concrete are they? What kind of projects are already springing up or in the cards?
Yes, indeed. So I'm not in the government anymore. So, but I'm still involved in hydrogen economy for sure. So our plans are very ambitious in Germany. You talked about these 10 gigawatt of installed electrolyzer capacity in 2030. We are a little bit behind of this plan, to be honest. But for sure, we look for all opportunities, not only wind projects, onshore wind projects or solar projects, but also for offshore wind projects. And you may know our plans in Helgoland. Helgoland is an island in the North Sea, 100 kilometers, 50 kilometers away from the coast around. And there we started 3 years ago when I was commissioned at this time with a research project, a 100 million funded research project. It's named H2 Mare, Mare for sea. And the idea was indeed together with Siemens Gamesa and RWE to develop wind turbines to produce hydrogen offshore. So two possibilities: to have a platform in between all these windmills in the sea, so collecting the energy around, or what is maybe more interesting, to have the electrolyzer directly on the windmill, on the platform directly on the windmill to produce the hydrogen offshore. That is one of the other ideas, and we spent 100 million for this research project. It's still ongoing. There were some disruptions, Siemens Gamesa has some problems. But anyway, the idea is to bring ideas on the table, not only to produce offshore wind, to bring the energy on the land and then put it in the electrolyzer, but really to produce hydrogen offshore. And when I visited Scotland 2 years ago, and I had a Scottish delegation here in Stuttgart 2 days ago, they have still also ideas to produce hydrogen offshore and also floating. There are some companies in Norway and in Scotland, they say we are able to produce also floating hydrogen on floating platforms like floating windmills. So that is very, very interesting. And so this is part of our plan to supply Germany with green hydrogen. We started some projects, 200 megawatt electrolyzer project at the moment. But as I said, to 10 gigawatt, it is a big challenge also for Germany.
Do you feel that things are moving fast enough, or what could be done to accelerate things?
Yeah, it's never fast enough, and as we talk about all these plans, talking about pipelines, talking about our core net, we decided now to build a core net in Germany for hydrogen pipelines, 10,000 kilometers until 2032. For sure, all these investments need public funding at the end. It's very difficult to do it privately, and if there's a lack of public funding, it will need more time. And it will be the same for all these plans we have in the European Union. We have the idea to build up to 5 hydrogen corridors, hydrogen pipeline corridors. One of it through the Northern Sea, so collecting the hydrogen from Norway, from Scotland, maybe from Ireland via Scotland. Or northern part of Germany, Helgoland, for example. That is one idea, or from the southern Europe via Algeria to Italy, or via Morocco, Mauritania, Morocco to Spain and France, via Spain and France, then to Central Europe. So all these are ideas, but to build such a pipeline will need, let me say, optimistically, maybe 10 years. And that is the big problem. We need the hydrogen, we need the infrastructure, but we need international agreements, and we need a lot of public funding to build these pipelines. So that's what we have to do together. It's not only a German task to build these hydrogen corridors, to build especially also Northern Sea hydrogen pipeline. But we have to start, and we have to think about the technologies. At the moment, it seems to be, as we talk about offshore energy at your conference, it's cheaper maybe, and a better business case to bring the energy from the windmills to the land, and then put it there to electrolyzers at the coastline. At the moment, seems to be a cheaper option, but technically, I think we will have opportunities in a few years also to produce hydrogen offshore. That is the plan, and I don't know if Lhyfe is in the panel and other companies are around in Nantes.
They
What
are
are their ideas? But the plan is really to have these technologies. But yes, we have goals in Germany to reach net zero in 2045. It's not it's 20 years from now on, so we have really to start now and really to spend public money for these infrastructures. Otherwise, we won't have without infrastructure, we won't have the FIDs. Maybe my last sentence. We have our big steel mills in Germany, a demand of 150,000 tons of hydrogen as a gas in 2027 in ThyssenKrupp in Essen, but also Salzgitter, also around 100 to 150,000 tons of hydrogen as a gas on the plant side. And that means, 150,000 tons means 1.5 gigawatt of electrolyzer capacity only for this, and maybe 3 gigawatt of renewable energy behind, only for one of these steel mills for the demand of 1 year. So that is what we are facing at the moment, and so that's
Right.
what we should fight for the public funding. We should fight for sure. We need a commitment of the industry, but they can't do it alone. That is quite clear.
Yes, of course. Well, thank you so much for your insight, Stefan. Kaufmann. Germany is one of the markets you are looking at. Baptiste Merlet, you're offshore project manager at Nantes-based Lhyfe, right?
You're right. Indeed, Germany is a market we are looking at, specifically on the Seine 1 project you may have heard of.
You've got slides, don't we?
Did?
Oh, no, you don't. You have slides.
No, I don't have any slides. Sorry. So yes, just to come back on the Seine 1 project, which is a very ambitious project, which is popped up in Germany for a couple of years now. The main characteristic of that project is they specify that we need to export the energy only through hydrogen. So it will be a fully integrated project. You have the wind park, and you also have the hydrogen facilities offshore, and then you need to export hydrogen and hydrogen only. So this is very, very ambitious, because we are talking about hundreds of tons per day to be exported. This call for tender was planned to be issued at the beginning of this year. Unfortunately, it has been a bit postponed. But you can imagine, when you have such a huge and very ambitious project, we already start to work to get prepared. You can't start for a big preparation of 6 months from scratch. You need to get prepared. You need to think about your concepts of what could be your capex, how you will operate it. So we worked a lot on that one. We feel prepared, and now we are ready for that call. I think the German government make some step backs about that one. They need to reassess the different risks. Maybe the ambitious was very big, so maybe they want to reassess it properly to make a proper call.
You have, your technology has been tested, I understand, at the 1 megawatt device of Croisic, and you've got other projects in the cards, right? Tell us a bit more about that.
Yes, totally. As you may know, Lhyfe is still a small company but big ambitious. When we are small, we need to start small, even for us, but also for the industry. So we need to make proof. To prove we can do it, so the best way to do that is to even being ambitious, is to start with a reasonable project, which was a Lhyfe project, a 1 megawatt project, which has been carried out 3 years and a half ago, and which has been in operation exactly 1 year ago during 6 months on this site near Le Croisic. We operated during 6 months, we collected some data, and we have a lot of lessons learned about that one. On two main aspects, I would say. For us, there is a part of which is our core business we want to deal with. It's about being operators. If you are an operator, you need to properly operate, you need to know your system. So these 6 months of operation offshore permits us to collect some data which has been post-treated and will be used for our operators. And in the other end, as an offshore manager, I really wait for lesson learned in terms of project management, of competencies increase. So the team we have been involved on the Lhyfe project could tackle some nice challenge about what is offshore, what's an offshore installation, what involves an offshore layout. You know, the footprint is a key of the success. What could be the safety design you have to deal with? So we had like a training, in fact, with that project on my team. And then let's say we tick the box for this first step, and now we are on the second step. For us is like a missing link between this small demonstrator to the real industrial project, which will be about hundreds of megawatts. We are dealing with a 10 megawatt project, a HOPE project. There is a presentation which will be done at 11 on the pitch area by our project manager Vincent Louvel. So feel free to get more information about the HOPE project.
You might be a bit late because this session will be over.
So please remain with us. So it's a 10 megawatt project. We will use a jackup barge, an existing one, a second-hand one, in order to go fast in terms of procurement. We use this jackup barge, make the integration at the construction yard, put our facilities on it, and then tow the jackup on the site and operate it. The main step we get on that project, for sure we get bigger, and also we could export and sell the hydrogen. So we could prove now the hydrogen we will produce offshore could be used by customers.
We heard of different countries yesterday, actually, in different panels, such as Denmark, such as Ireland. Ports were here to speak, harbour authorities, and they were saying we are going to use green hydrogen. We need green hydrogen because we're likely to produce too much renewable energy in the future. Are you in touch with them at all, or with players abroad, with harbours, with developers in other countries?
Yes, we are. It's a difficult market for sure. There is different way of thinking depending on the countries. You have, like Germany, we are very ambitious, talking about the Seine 1 project with a clear specification of what they do. You also have, on the other hand, the Netherlands. We make announcements about the Demo 1 and Demo 2, and you have other countries where the potential is very huge, like in UK, Scotland, Wales, Ireland. There is a lot of winds. They have grid network issues. So there is a real sense of producing hydrogen over there. We need to work with them more than we are doing again and again. But for sure, this is a huge playground for us, specifically, I would say, specifically in Scotland, because they have all this oil and gas history and background, all the skills over there, all the assets, and it's a real it's a real positive thing for us to switch this let's say dying economy. I would say maybe not dying, but it's a bit strong. But yes, to switch it and to use it for hydrogen.
All right, thank you so much, Baptiste Merlet. With us is also Elin Steinsland, I'm sorry. I'm going to get this right. You're CEO of Norwegian developer Hydepoint, and you brought some slides. Can you tell us a bit more about your technology?
Yes, I can. So, can you see my slides? I can see it.
We will.
Yeah, here it comes.
We can.
So, first, just a brief introduction. So, Hydepoint is a technology company owned by Norwegian industry majors, such as the Kongsberg Group. So what we do is really to leverage decades of experience from the offshore oil and gas industry to make these large offshore hydrogen process plants. So you can see examples, and I mean, our German panelists here asked for both floating and bottom fixed. You can see it here. We actually started out with a floating unit, and that's because we have floating in our backbone in Norway. We've got a lot of deep water, so it was kind of a natural thing to start there. So we proved that this is possible to do. This is all based on kind of 3D modeling, simulations. We did the calculations and so on to understand that we can actually produce hydrogen offshore at a cost that the market can live with. But as Lhyfe already told you, that's not where we are at the moment. At the moment, we are at the smaller plants, testing out the technology. And what you see also here is a 120 megawatt plant. The floater is actually a 500 megawatt unit. So our ambition in Hydepoint is really to make sure that all the energy from offshore wind is reaching the market. And as we have heard already at this conference, this is challenging already today. We have grid issues. And what will happen when we continue to size up renewables in the kind of total energy mix is that this is going to be even more challenging. So our proposal is to convert a lot of that energy into hydrogen. To do that, we are making these platforms, and our platforms are really pure building blocks. So we got like 5 building blocks. I'm not going to go into details on what we do, but the whole idea is to make building blocks that can be fully qualified and then sized up. So what we are working on right now is kind of a couple of building blocks. It's the balancer stack. That's kind of the heart of the system. It's a 20 megawatt unit with the electrolyzer stacks and all the electronics and everything that goes with it, combined with a water polishing system. So these can come in 20 megawatt units, and then you can continue to size them up to 40, 60, and 80. So these are systems like developers like Lhyfe can use in their scale-up projects. So in addition, we have modules on the water intake side. It's seawater cooling, kind of closed-loop cooling systems, everything that you need really to desalinate the water and make the plant ready. Of course, lots of electronics, high-voltage systems, and so on. That's another one. On the export side, we have hydrogen purification and everything needed to link to a pipeline subsea.
And how far advanced are you with these projects, or how many concrete projects are in the pipeline?
Yeah, at the moment we are planning for a pilot for the 20 megawatt unit. So we are actively looking for test sites. We need offtake, of course. With a 20 megawatt unit, there's a lot of hydrogen, so that needs to be taken by by an end user. So currently moving into detailed engineering, looking for a test site for this.
All right.
Yeah, so in addition, we're also working with like digital concepts, and we are developing a digital twin. That's really just a computer model of the setup. But when you have that twin, you can use it to test and analyze upfront without really having to run a lot of different physical test scenarios. So that means that you can run what-if scenarios and understand how different technologies will affect your setups. You may want to change your electrolyzer, for example, from one supplier to another, and then it's important to test it. So a twin is a unit that reduces the risk of the project. It takes down cost, and it also makes it possible for you to test a lot of different scenarios. So in addition, what is really interesting with a twin is that you can integrate the operating system with it. And that allows the operator sitting onshore to really do a lot of testing in the early phase, which potentially can reduce commissioning time a lot, and also training of the operators. And in a kind of very mature state, a twin can actually perform parts of the operation of the system, like smaller maintenance operations, like understanding, getting inputs from the system, sensors, understanding what is required to do, maybe swapping between different redundant systems and so on.
All right. Just before I let you go, how close is this market to reaching the commercial stage, do you think? What's in the way?
Yeah, I think we heard it already, both from kind of Germany here and from Lhyfe, that that there are things that needs to come together. In hydrogen, we often talk about the chicken and the egg challenge. So we need the end user to be ready. I mean, there needs to be offtake. But the end user also needs the hydrogen to be there, and they need the infrastructure. So and also for offshore, of course, we need offshore wind to size up. We've seen some kind of tumblestones on that the last year, but I think we are now seeing things changing. So. We see, again, from Germany here, we heard the industry really preparing for hydrogen. The steel industry, a very good example. So that also means, together with the European hydrogen backbone, where we see they are starting to plan and gradually build this infrastructure, that it will come in place. But it will take time. And the large kind of offshore plants will probably not be there until like in 10 years from now, but there are so many steps that we need to go through before we are there. So, you know, we need offshore wind, we need that energy for the energy transition we are facing. And the wind developers with hydrogen, they can optimize their production. Hydrogen can offload the grid and add flexibility, and also the industry will get access to these large volumes of hydrogen that is needed really to be in line with all the international agreements we have signed. So I would say I'm positive, but we need to kind of do the baby steps first and then gradually be there.
Well, we're all looking forward to that. Thank you very much, Elin Steinsland. Thank you, Baptiste Merlet. And thank you, Stefan Kaufmann, for connecting remotely to us. Thank you for listening.
Thank you.
Thank you.
Greetings to Nantes.
Thank you, Stefan.
Yeah.